Okay, guys, I made a mistake yesterday. I realized at the end of the recording I said, of lesson 28, I said, I'll see you tomorrow for lesson 27. I should have said for lesson 29, so please forgive me. Lesson 29 is going to be a fairly easy lesson, I believe. It is on negative exponents and zero exponents. So negative exponents is definitely going to be a little bit more something to think about than zero exponents. So let's talk about negatives first. I've given you some visuals here to see what a negative exponent is going to be transposed to make it positive. So here, for example, if you have x to the negative b, you can't have a negative exponent, so you're going to have to find a way to make it positive. And the way you do that is you simply move it. If it were in a whole number like this, you're going to put it on the bottom of a fraction under the number 1, just like this, 5 to the negative 2. We're going to make this a positive by putting it under the number 1, and then when we solve, we're going to have 1 over 25. Alright, so I've given you a couple of examples down here. 1 times 3 to the 4th, if I were going to make that positive exponent a negative, I would simply make it a whole number, 3 to the negative 4th. This term and this term are identically the same. Okay, we've just gotten rid of the negative exponent in 1. Same thing here, 7 to the negative 2nd. If I write that as 1 over 7 squared, then that's going to be the very same thing. These two represent the same number. Okay, go to the next page. So here's your negative exponents rule. A to the negative m equals 1 over a to the m. A negative exponent means we have to rewrite our power term as a 1 over fraction. Negative exponents are positive fractions. And note, this is important, a here cannot be 0 because it is impossible to have 1 over 0. That's not possible. Okay? Alright, go to the next page and let's talk about zero exponents. Zero exponents are just so easy because x to the 0 is 1. Anything to the 0 power is 1. And I've illustrated that here 3 different ways for you. Each one of these expressions, no matter how long it is, at the end it has to the 0 power. So that means each one of these is equal to just 1. All right, go to the next page and let's look at the rule for that. So the power of the zero exponent. Okay, so if we have 2 to the third over 2 to the third, we have 2 times 2 times 2 equals 8, and the same thing on top and bottom, which equals 1. Okay, or we could write it like this: 2 to the third over 2 to the third equals 2 to the third minus 3, which equals 2 to the 0, and 2 to the 0 still equals 1. This just shows you why it equals 1. Alright, go to the next page. Let's work our practice problems here. Alright, first of all, we're going to rewrite this as 2 to the third, which is equal to 8. And negative 4 to the negative second, we're going to write that as 1 over 4 squared, which is 1 over 16. That's what it's equal to. Alright, 1 over negative 3 to the negative second, we're going to make that a whole number, negative 3 squared, and this was in parentheses, so that negative sign is protected, so it means negative 3 times negative 3 equals 9. Alright, 8 to the 0 power is equal to 1. Now in E, negative 8 to the 0 power, it's still 1, but this one is negative 1 because this negative sign was not protected. It attaches to whatever. The 0 power is only over the 8, not the negative 8. Now, this one's going to be a little bit different in F. Then it applies to everything, so it is going to be positive 1. All right, go to the next page. And here again in G, doesn't matter what all this is, it's to the 0 power, so it is equal to 1. All right, now let's solve by combining some of these variables, these exponents, I'm sorry. So let's take our x's first. We have 3 x terms. We have negative 3, positive 4, and positive 2. So 6 minus 3 leaves us with x cubed, or x to the third. And then y, we have negative 8, positive 5, and negative 8 and positive 5 leaves us with y to the negative third. And then z, we have a 1 right here and a 5 right here, so we end up with z to the 6th. Alright, and in this one, we've got x to the 6th and x squared, so we combine those and we'll have x to the 8th. Here we have y to the third and y to the negative third. Well, they cancel each other out, so our final answer is just x to the 8th. Next page. Alright, this says use the distributive property, remember from a few lessons ago, to expand this expression. So we're going to distribute this over this, and then over this, and see what we get. Okay, we're going to have 2. X to the negative second times x to the second cancels each other out. Y to the third times y is y to the fourth. Alright, and then minus, and 2 times 3 is 6. X to the negative second and x to the negative 1 is x to the negative 3. And y to the third and y to the negative third cancel each other out. So this would be our final answer. Alright, it's been a pleasure today. I will look forward to seeing you tomorrow for Lesson 30. Yay!